This is example 14.6 from Discovering Design with Chemistry. Determine the value of the change of S for the following reaction at 25 degrees Celsius. That piece of information specifically helps us to know that we can use the table on the previous page that gives us absolute entropies. And then it gives us the reaction shown. Because my whiteboard does not like to put things like subscripts, I just copied the information from the table over here, but I wrote the words for each of the pieces. Like instead of H2O2, I wrote hydrogen peroxide. All right, so to do this, we just simply use this formula that we recently learned right before getting to this example. So to find the value of delta S, we're going to start with the products and add their absolute entropies and then subtract the reactants. And we multiply each of those absolute entities by the number of moles that we have going on. And so we're going to start with our products, which is this side. So we have 2 moles of H2O in liquid form, and that one, water, is 70.0. And the unit for that from the chart is joules per mole, which is why I put the word moles here so I could mark out the units. And then we're going to add to that. Next we have 1 mole of oxygen gas. Let's just take that out. All right. Times 205.0 joules per mole. I really should have written that over here on all of these. All right, and now we're going to subtract the reactants, which is just 1. We have 2 moles of H2O2, and that is 143.9 joules per mole. Let's go ahead and mark out our units that cancel, and we're left with just some things to add together. Remember, we can't have a piece of a mole, so the 2 or the 1 doesn't have anything to do with significant figures. We're just like adding 70.0 plus 70.0 plus 205.0 minus 143.9 minus 143.9 again. But because that would take longer, we're multiplying. So let's pull up the calculator so you can watch me do it. All right. 2 times 70.0 plus 1 times 205.0 minus 2 times, and then I gotta put, I guess I technically don't have to put that in parentheses because it wasn't negative. That's okay. All right. And that gives me an answer of 57.2. And because all we're doing is adding and subtracting, all we care about is the least precise number, but all of these are to the 10th place, so our answer is still to the 10th place. Change in S is positive here, and that's what we would have predicted if we had done the same things we did in the last section where we looked at the fact that this went to from aqueous, so like liquid on this side, to liquid and gas on that side, and we went from 2 molecules on the reactant side to 3 molecules on the product side. So we are gaining entropy, so we would expect a positive number or a positive sign for change in S. 57.2 joules. All right. Oh, just kidding. I need to put the K. I don't think I put the K on the bottom of any of my little things. Mole times K. Mole times K. Mole times K. And all of these to have the same thing. Joules per mole times K. All right.